Hello and welcome to another one of these ADD videos. Today we're going to be trying the technique of factoring by grouping, and we're going to look at this quadratic equation. I'm pretty sure most of you can guess your way to the solution, but this is an exercise in practicing factoring by grouping. And you will see that it will be a lifesaver on some of the more complex quadratic functions if you learn this technique. So what's the first step? Well, if you remember, the first step is to take your A times your C to figure out what we need to break down. So A is 1 if there's nothing there, coefficient of x squared, and C is a constant. So A is 1, C is 6, their product is 6. So we are looking for factors of 6 that add up to the middle term B, in this case 5. Or subtract. Actually, in this case, since this is plus and plus, they need to add. Okay, there is no subtraction. If the second term is a plus sign, they both need to be whatever this sign is. Again, if this is a plus sign, they're both going to be plus. Or if this was plus and then minus, both of your parentheses should have minuses in it. But if there's a minus, then one's plus and the other one's minus. Okay? Alright, so once we know that, we ask ourselves, what are the factors of 6? Well, 6 and 1, and their negative counterparts, negative 6 and negative 1, 2 and 3, and negative 2 and negative 3. Their negative counterparts aren't going to work because we have a positive 5, and we see that 2 plus 3 does equal 5. So then once you figure out your factors are 2 and 3 that multiply to 6 but add up to your B term 5, you break your 5x into 2x plus 3x, which still equals 5x. We're not changing the integrity of the problem, we're just changing its appearance. Alright? So once you break apart your expression into the two terms, you should have 4 monomial expressions added together, and you can group the first two together and the last two together and factor out what's common. So in the first two terms, what's the greatest common factor? Well, I see that there's an x common to both of these. And then the last two, there's a 3 common to both of these. So I pull them out using the greatest common factor technique. So I've in essence grouped them together. That's where the name comes from. So once I factor it out, I'll be left with x times x plus 2 plus 3 times x plus 2. The way you figure out what you had inside the parentheses is you take what you had originally and you divide by what you're factoring out. So x squared over x gave me x, 2x over x gave me 2. 3x over 3 gave me x, and then 6 over 3 gave me 2. And if you did it correctly, this and this should be the same thing. If not, you either made a mistake or you just can't factor this expression. Since they did equal the same thing, I know I'm on the right track and I can factor out the x plus 2. Just like I factor out the x from these two and the 3 from these two, you should see that there's an x plus 2 common to both of these expressions. So when we factor out the common x plus 2, you'll notice what we have left is going to be the expression in front of the parentheses. So x plus 2 factored out of both of these is in front. That's the term we factored out. And then we're left with this plus this in the second parentheses. And so again, this is just pointing out that the coefficients are what is left in the parentheses. And that's basically factoring by grouping. Seems like a lot of work, and you might not be inclined to learn it right now just because it seems overwhelming and new and different than what you're used to. But trust me when I tell you, if you learn this technique, you will be happy later on, because there will be a problem where you'll be asked to solve a quadratic and it won't be so obvious. What do you do then? So that's the beginner example. Make sure you check out the intermediate and advanced examples. They'll be a little bit more challenging, and hopefully the advanced one will be challenging enough to convince you that this technique is the way to go. As always, practice, practice, practice. And thanks for watching. Have a great day.